gravitational force of attraction between Earth and the Sun is 3.52 times 10 to the 22nd newtons. Calculate the mass of the Sun. The mass of the Earth is 5.972 times 10 to the 24th kilograms, and the distance between the Sun and Earth is 1.496 times 10 to the 11th meters. I have already listed all of the given information, and we're going to try and find the mass of the Sun. So we're going to take this formula, which is force is equal to the gravitational constant, m1, m2, which is the mass of the two objects, divided by the distance squared. I'm going to rearrange these variables, and I'm not going to show you the work for that, but I'm going to move the distance over to this side, and it's going to get multiplied. And then since the gravitational constant and the mass are being multiplied, they will end up divided. So when I rearrange this, I'm going to have the mass of the second object is equal to the force times the distance squared divided by the gravitational constant and the mass of the first object. And the second object is the Sun, the first object is the Earth. Okay, so now that I have that, I can plug in my numbers and do the math. So, mass of the Sun is equal to, the force is 3.52 times 10 to the 22nd newtons. The distance between the two objects is 1.496 times 10 to the 11th meters divided by the gravitational constant, which is a given, 6.67 times 10 to the negative 11th. That's newtons meters squared over kilograms squared. And the mass of the first object, which in this case is the Earth, which is 5.972 times 10 to the 24th kilograms. So I believe that it's easier to take this formula and rearrange it into this. It's a great skill because now instead of trying to multiply and divide to solve, it's already solved. I just have to type in the numbers. So I type in all the numbers right here. Oops, I forgot one little thing. This is distance squared, so I have to square this as I type it in. So, oops, I forgot about the bell. Let me try that one more time. Okay, let's do the math. 3.52 times 10 to the 22nd times 1.496 times 10 to the 11th squared, and that is divided by, I'll put this in parentheses, 6.67 times 10 to the negative 11th times 5.972 times 10 to the 24th. And that is my entire answer, 1.977699108 times 10 to the 30th. Now let me check real quick my numbers. I have 3.52, 1.496, 6.67, 5.972. 3434 as far as significant digits. So I'm going to round down to 3. So I'm going with 1.98. 1.98 times 10 to the 30th, and this is the mass of the Sun, so that is in kilograms. Now, real quick before I finish, I am going to go on to Google and type in, what is the mass of the Sun? And Google's going to tell me that it is, Google says 1.989 times 10 to the 30th kilograms. And I personally think that's, we did pretty good. Now we're off by a little bit, but obviously there's some rounding error as always. But the challenge here, like I said, isn't always setting this up, isn't always that. Make sure that you can actually type this into the calculator and get that answer. That's a little bit of a challenge.